Welcome, everybody. Good morning. The plan today is we're going to talk about something that is every Algebra 2's students' least favorite subject, which is a bummer because it's so easy and so simple in a way. But we're going to be talking about imaginary numbers, which is definitely a little cringe in a way, right? I mean, some of us don't even like working with real numbers. And we're going to spend a whole week talking about imaginary numbers. And it's a very weird process of these are literally imaginary numbers that are not real, that don't really exist, but they exist enough for us to learn about them. So they do actually exist. It's a very weird thing. And it's definitely something where you could go home and you could say, hey, Grandma, guess what I learned about today in math class? I learned about imaginary numbers. And she'd say, is your teacher crazy? But she wouldn't be wrong, right? We have to learn about imaginary numbers. But if you just tell yourself, you know what, I'm going to get over it, I'm going to learn imaginary numbers, then at the end of the day, you'll realize it's pretty straightforward, okay? 90% of the skills of what we're talking about are skills you already know how to do, and so we're just going to introduce these new things. Basically, imaginary numbers come from the square root of -1, okay? Now, this is something we've already talked about. Like I said, most of this stuff comes from stuff that you already know. Imaginary number comes from the square root of -1 because this right here is impossible. The square root of -1, this is, a paradox. You cannot have two numbers that multiply together to make a negative. If you have -1 times -1, that equals to +1. And so -1 squared is +1. And basically, there's no number you can choose that would satisfy this example here, okay? There's no way at all we can take the square root of -1. It just cannot happen. There's literally no way we can make it happen. So, all that being said, what we're going to do is we're just going to pretend like we can do it, okay? We're just going to say, hey, you know what? We can totally do this. We're just like lying to ourselves. And we're saying this is totally fine, okay? And what we do is we put a symbol that looks like this, and it is a lowercase I, but it also has a little bit of a hook on it. And if you're in class, you don't necessarily have to take notes just now. We'll catch up in just a second. But and this is us just saying, you know what? I know that this is impossible. I know that this doesn't make any sense. I know that this is literally not able to be done. But let's just pretend. Okay, let's just say that it's okay for now. And let's just move on and, carry on as best we can, even though we've had something that doesn't make any sense. Let's just go forward with this and hang out. Now, the reason that we do this is because when you get to higher math, a lot higher than high school math, but sometimes if you want to solve a question, you have to go into the imaginary land where nothing really actually makes sense, and then eventually you'll be able to go from the imaginary land back to the real life math world. And if you don't know how to take this kind of leap of faith, then you'll never be able to get back to the real world to where the answer is. It's a very strange thing. It's basically us just pretending that things work, even though they don't really work. Now, in Algebra 2, you have to learn something really simple. This is about 60% of what you need to know for this whole week, that the imaginary numbers come from negatives on the inside of a square root. Now, we need to be extra careful. I just want to mention really quick, the cube root of -1, that's just -1, okay? This is totally fine. This is absolutely okay. Cube roots are different than square roots. We're talking about square roots that will make an imaginary number. When it comes to cube roots, that will not make imaginary numbers. So, all that being said, the square root of -1 equals this. And this is an I, even though it kind of looks like a backwards J, it's an I for imaginary. Now, what we're going to do is basically treat this I like a variable, and we're going to just do some math from there. So, for example, let's go down and let's solve a question like 5. I know we're skipping around, we're skipping all over the place, but if we go down to question like number 5, the square root of -4, this question is impossible, right? There's no way to do this question. You cannot take the square root of -4, but we're going to pretend like we can do it. We're going to say, I know it doesn't really make any sense. You cannot do the negative of or the square root of a negative, but what if we just took this negative and we just made it I square root of 4, okay? And basically, we said the negative inside the square root, gross, doesn't work. Let's just eliminate that negative. We'll hold on to it as an I, and then we'll just continue and solve the question from there. So obviously, solving this question, the square root of 4, this is now totally cool. Square root of 4 is easy. That's 2. And so the answer would be 2I. And that's the answer. And again, that's not a very difficult process to do. You've literally just removed the negative and then done the square root of 4, which is a pretty straightforward process. Now, this 2I is not a real number. This is a totally fake imaginary number, and it is not just a 2. It is a 2I. The way this I will work is just like a variable, but we'll see that in a little bit. And so if you look at number 6, it's the same idea, right? This negative, we'll just bump it outside. We'll call it the I square root of 81, right? We cannot do this, but we can say it's the imaginary square root of 81. Then we do the square root of 81 and we get 9, and it's 9I. So that's a piece of cake. This can even work for numbers that are not perfect square roots. Okay, so if you look at numbers like question number 9, question number 10 here, square root of -20, it's the same idea. You just pop out the negative. Even though this question is impossible, we're just going to pretend like it is possible. Then we're going to go ahead and split this up just like we did last week. 4 and 5, 2 and 2. We're going to say that the 2's are going to come outside with the I. The 5 is left over. And so we've got 2I square root 5. And so if you already know how to simplify square roots, we've added a tiny, tiny, tiny micro step to this whole process, okay? We've identified that if we have a square root that is literally impossible, we're just going to pretend like it's cool. We're going to put the I out front. We're going to do everything else exactly the same. And then we just need to hold on to this I. We just need to hold on to this I as if it were a variable. Just keep track of it and don't forget about it. That's why I like these arrows to remind me that the 2 is coming out front with the I. That way I don't forget the I that's out there. But I think it's best to do this in the very first step so that it makes it as straightforward as early as possible. Now, if we look at some of the other questions, we can handle 10 the same as 9. We can handle 11 the same as all of these. Number 12 is a little funky. Looking at number 12, we have addition here. And remember, when it comes to addition, we can only add square roots if they have the exact same number on the inside of the square root. So, handling this is impossible, but we can pop the negative out front and we'll have I square root 5. Handling this one, this is impossible. We can pop it out front and we'll have I square root 45. Sorry, that's a little hard to see. I'll write it with this pink color. And right now, we cannot add these two square roots together because they do not have the same insides. And so we'll need to do a little simplification. We'll need to do 9 times 5, 3 times 3. I need to make my pen a little bit smaller. And obviously we have pairs of 3s. And so we've got a little bit more room. We've got I square root 5 plus 3i on the outside, square root left over 5. So now we've got basically an imaginary square root of 5 and 3 imaginary square roots of 5. And so adding these together, this is like if we had, 1 imaginary apple and 3 imaginary apples. And so we add them together, we've got 4 imaginary apples. Okay, this I is treated exactly like any other variable. Okay, it's treated just like an x. And so, we don't actually change these two i's when we add them together, just like if we did, 3x plus 2x, and we would say that was 5x, right? It doesn't actually change the i's, it just adds them together. So, all that being said, we've basically added one tiny, tiny step to the front of our radical questions, okay? And that tiny step is just literally take the negative, throw it out front as an I. That's the only new thing that we've learned, okay? It's the very, very first step, and we get rid of it, and then we're chilling. Now, if you look at the powers of I a little bit differently, or if you look at I a little bit more closely, a lot of times you'll run into questions like this. What about I squared, or I cubed, or I to the power of 4? And in particular, I squared, I cubed, and I to the power of 4. These are the powers of I that really you're supposed to memorize when it comes to Algebra 2. And you need to memorize what each of these things are. Okay, now, looking at these, I'm going to go ahead and give myself a little bit of time to work up here. You can memorize them as just things to memorize, or you can kind of work with I a little bit, and you'll understand them if you work with it a little bit, okay? I is the square root of -1, okay? And so if we keep that in mind, that I is the square root of -1, then what is I squared? That would just be the square root of -1 squared. And just like Jamaris was saying there, yeah, if we have the square root and the squared, these two things are opposites. These two things are going to cancel out. We will find out that I squared is -1. Okay. Now that is a huge, 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 huge realization. Okay. And this is what I was telling you about, where sometimes if you go into the imaginary world, then sometimes you'll be able to come back to reality somehow. And this is how it happens, okay? If you have two imaginary numbers and you multiply them together, that would be like if you had two square roots of -1 and you multiplied them together, and that would be totally fine, because the square root of -1 times the square root of -1, multiply the outsides, multiply the insides, you're going to get a +1, which is a piece of cake. So anytime you can combine two i's with multiplication, you're going to get -1. And so that is a really interesting thing you'll have to keep in mind. That is something that you'll see, quite a bit this whole week. I squared equals -1. If you have to memorize anything this week, it's this right here. I squared equals -1. This is our key that's going to get us out of the imaginary land once we go into it. So on our little table here, we definitely want to make a table like this. I squared is -1. And what I would recommend, if you like taking nice notes, is to give this box a little extra, color, because that is the super important. Out of all four of these, I squared equals -1. That's the most important one that you really want to memorize. Next up, I cubed. The way I cubed works is that would be like if we had, and again, this is me trying to explain it to you, that would be like if we had I squared times I, right? That would be I cubed. And we know that I squared is -1. And so -1 times I is just -I. And so I cubed is -I. Now, again, you don't have to memorize this. If this confuses you, that's totally fine. Just make sure down here that you write -I, and that you're able to memorize that I cubed is negative I. So what you're probably thinking is we were imaginary, and then we came back to real numbers, and now with I cubed, we've gone back to imaginary numbers again, which kind of sucks. But if you're kind of really thinking ahead and you're great with patterns, you're probably thinking to yourself, if we go from imaginary to real to imaginary, we're probably coming back to real, okay? And the way that this works is that if you have 4 i's multiplied together, that would be like if you had I squared times I squared. That's 4 i's right there. And if you have all 4 of these, that's like -1 times -1. And so all 4 of these is just a 1. So these 4 are 4 numbers that you need to memorize. I equals I. That one's a little silly, but I equals I, sure, that's fine. I squared equals -1, we talked about that. I cubed equals -I, we kind of talked about that. And I to the 4th equals 1. That one is just to finish us off. Now, how do you memorize this? I've had students think about, a way to memorize it as I, -1, I, 1. And students will say, I won. I won. Like you're extremely excited that you won the soccer game, right? I won. And that's how they remember it goes, I won. It's a little silly, but that's, an easy way to memorize things somehow. And then they just remember that the middle 2 here are the 2 with the negatives, okay? And they'll throw a negative on the middle 2, and then they'll be done. So they'll see this, they'll say, I won, negative, and boom, they've got it all memorized. You don't have to memorize it that way. That's just a silly way to keep it in mind, but I've had students who they memorized this and they learned it in 10 seconds. Now, why, this is one of the last things you're going to do today, I promise, but why do we only go to I to the power of 4? Why is I to the power of 5 not important anymore? Why is I to the power of 6 not important anymore? You got an idea? Yeah, I got you. 100%. I like the way you're visualizing that with your hand. What's going to go on is since we've gone back to 1, and this is kind of like a blank slate, okay? If we have I to the 4th, I to the 5th would be I to the 4th times I. That makes I to the 5th, but I to the 4th is just 1. And so I to the 4th just kind of disappears. And so when we get to I to the 5th, it's really just a regular old I. And what's going on here is that the way this works is you count, this is I to the power of, this is I to the power of 1, 2, 3, 4. And then once you get here, it just resets and goes back to here. And so this would be I to the power of 5, I to the power of 6, I to the power of 7, I to the power of 8, and then it just resets. Goes back to the top. I to the power of 9, 10, 11, 12. Because every time we get to the 4th power, we go back to 1 and it all kind of disappears for us. So what you need to memorize is not only these 4, powers of I and what they're equal to, but you also need to be able to handle questions like the first 4 questions, okay? I to the power of 7. So here's what we're thinking. I'm thinking I squared, I cubed, I to the 4th. It goes I 1, put some negatives in there, and now we're feeling pretty good, okay? So here is our memorized little table. That comes up pretty quick. And when we need to count up to I to the power of 7 and it resets after 4, we can count it up like this, 1, 2, 3, 4, reset, 5, 6, 7. There you go. So this is the same thing as I to the power of 7. And so what we would want as our answer would be, there's our 7, would be -I. Okay, this is our answer. I to the 7 is basically I cubed, and I cubed is negative I. And so that is why we would select that as our answer. So same thing with 12. Okay, a way a lot of students do it is they will say, you know what? I'll count to 12. They'll say 1, 2, 3, 4, reset. 5, 6, 7, 8, reset. 9, 10, 11, 12. I to the power of 12 is the same thing as I to the power of 4, which is just 1. So they'll say 1. That's the answer. So you need to know how to do this process. It's not super difficult, though, if you can memorize these, this little table right here. Oh, that's not a very good way to outline it. Let's do a different color. If you can memorize this table right here, then you can solve any of these questions by just literally counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and you just pick the one that you land on. Okay, it's not a really mathy type problem more than it is just a counting problem. Now this answer was 1. Sorry for erasing it. Now, sometimes though, we get to a question like number 3 and number 4. Okay, and guess what? We are totally, we're totally capable of figuring out what the answer is here, right? We could say I squared, I cubed, I to the power 4th, and all of these things are equal to. Again, I think the easiest way to think about it is I1, put some negatives on the inside, and there's our little table. If we want to get to 34, it's time to start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's the thing, though. At some point, you're going to get too lazy to do this. Okay, when it's 93, that's going to suck to do all of these 93 hash marks. Counting 93 is not fun. So we needed some sort of shortcut, some sort of way to figure it out. And the easiest way to do it is to think about, in my mind, subtracting 4. Okay, and the reason I like to subtract by 4 is because if we subtract by 4, we're basically going to cut out one loop, right? Because if we need to do, one loop, and then we need to do 2 loops, and then we need to do 3 loops, and then we need to do 4 loops. Every time we subtract this number by 4, we're going to cut away one of these loops. And then we're going to cut away one of these loops. And that's okay because, we know that this is the same thing as I to the power of 5. And this is the same thing as I to the power of 6. And so it's okay if this number is reduced by 4, because we know that these things are the same. It's okay if this 6 turns into a 2, because we know they're the same. And so what I would do is subtract this number by 4. And I would say I to the power of 34, that's the same thing as I to the power of 30. And I would say I to the power of 30, that's the same thing as I to the power of 26. All of these are the same. And every time I subtract 4, I'm saving myself a bit of time. Now, here's a really nice life hack if you can keep track of it. Subtracting 4 can also be a little slow. So you could subtract 8, and that would be subtracting 2 laps. You could subtract 12, and that would be subtracting 3 laps. And so what I like to do is subtract 4, or I like to subtract 20. And I like to subtract 20 because that's just an easy number to subtract. And this subtracting 20 is basically subtracting 5 laps of our number here. You got a question? Exactly. Multiples of 4. You've nailed it on the head, right? Any multiple of 4 you could subtract. So I like to either subtract 4 or subtract 20. That makes it really easy for me. One thing you could do is you could say, what's the closest multiple of 4 to 34? You could say, 32 is the closest one. You could subtract 32, and then you have I squared, and you would know from that. That is totally fine. That is, even for me, maybe a little bit too high IQ to kind of work out for every single question. What I would do if I was going to solve I to the power of 34 is I would say either subtract 4 or subtract 20. I would subtract 20 and I would get I to the power of 14. And then you know what I would do? I would say, I'm not too lazy for that. I'll go ahead and count to 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There we go. -1 is the answer. Okay, so you don't have to go all the way down, just down to the point where you're not too lazy to count anymore. And so once I got to 14, I'd be cool with that. Now, working with that same strategy on number 4, I to the power of 93, I would think, wow, I definitely don't want to count that high. I definitely want to, shorten my amount of counting I have to. I definitely want to lessen this number, make this number smaller. I would say I1, put the negatives on the inside there. And I would start by subtracting numbers. Now, I could subtract 4, but that would be slow. So I'll subtract 20. That's pretty easy. 93 minus 20 is 73. So I've got I to the power of 73. And I'd think, still too lazy to count to 73. So I'd subtract 20 again. I to the power of 53. And I'm probably still too lazy to count to 53. And then I'd subtract 20 again. I to the power of 33. Probably still too lazy to count to 33. And then I'd subtract 20 again. I to the power of 13. And now I'd think, you know what? I'm not too lazy to count to 13. I'll do it. It's a little annoying, but it's not too bad. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And so this is our answer. I to the power of 93 is exactly the same as I. And so my answer would be I. Okay, that is imaginary numbers. That is everything you need to know about imaginary numbers. A quick recap. You probably want to know this, that I comes from the square root of -1. Okay, that is the problem that we had, and I is the solution to that problem. Okay, now from there, you want to know that if you have a question that is impossible, like the square root of -81, we're just going to use I as a really quick way to solve this impossible question. We're going to pull it out. We're going to say this question is impossible, but it would be 9 if it wasn't impossible. So we keep that I. And then the last thing you need to know with imaginary numbers is our I table, or the powers of I. You need to know it goes I, -1, -I1, and that it loops back to the start every 4 numbers. So keep all that in mind. At the end of the day, this work becomes pretty easy once you get practice with it. And yes, working with imaginary numbers is a very silly proposition when you first start. So I applaud you guys for being brave and just knocking it out. All right, that's the end of the lesson. Great job. It's kind of a long lesson, but that's it for imaginary numbers.